Hi all. Now we are going to see first come first serve scheduling. Before that, we have seen a lot of about CPU scheduling. In this CPU scheduling, we can see the various types of scheduling which belongs to CPU scheduling. First one, first come first serve scheduling, which means the job which comes first in the ready queue will get the CPU first. How it works? Let's see. Let's take a three process with burst time. First process 1, 2, 3, along with burst time, process 1, 24, process 2, 3, process 3 and 3. If we want to use the CPU efficiency, we can take the first process which can have the less burst time. But in this scheduling, it is called first come first served. Which process enter to the CPU first, we can take that process. So in that model, we can take only process 1 which can have the highest burst time, 24. So we can schedule this process with burst time in Gantt chart. Gantt chart. So let's take the example with the Gantt chart. P1 take 24 milli. For example, if the burst time can calculate by milliseconds in the sense, P1 can take the 24 milliseconds. Then next arrived process is process 2. Its burst time is 3 milliseconds. So 24 plus 3, 27 milliseconds. The third process P3 with 3 milliseconds burst time. So 27 plus 3, 30. So the entire process, all three processes execute in the CPU with 30 milliseconds burst time. So how can we calculate the waiting time for every process? P1, it wasn't wait for any other process. So it is the first process to execute in the CPU. So there is no waiting process. It's zero. Then how can we calculate the process 2 waiting time? In the sense, process 2 should wait, which process P1 can execute, which when process P1 once process P1 executed first. So P2 waiting time is 24 milliseconds. Then P3. P3 must wait until P1 and P2 process completed. So P3 waiting time is 27. So what is the average waiting time is P1 is 0, P2 is 24, P3 is 27. So 0 plus 24 plus 23 divided by total number of process 3. So the average waiting process is 17. Then next, shortest job first scheduling. Shortest job first scheduling means associate with each process the length of its next CPU burst. Use this length to schedule the process with the shortest time. So before first come first serve, the process which comes first in CPU, we can take that process execute. But in shortest job first, we can take the process which can have the less burst time. That is shortest job first. There are two schemes, non-primitive and primitive. Non-primitive in the sense, once the CPU given to the process, it cannot be preempted until completes its burst time. Preemptive in the sense, if a new process arrives with CPU burst less than the remaining time of the executing process, preempt. This scheme is known as shortest remaining time first. So obviously, yes, shortest job first is much better and much efficient than job first, so first come first serve. Okay, next, the last scheduling is round robin. Each process gets a small unit of CPU time, usually 10 to 100 milliseconds. After this time has elapsed, the process is preempted and added to the end of the ready queue. If there are n processes in the ready queue, the time quantum is q. We can calculate the sum of the time quantum. Time quantum, then each process gets 1 by n of the CPU time. Its chunks at most q time units at once. No process waits more than n minus 1 q times. So this is the round robin. Thank you.